Today's topic is free fall, and we will start from here. Earlier, we have read about the universal law of gravitation and its calculation, and we got a different kind of formula that is F equal to capital G into capital M into small m by d square. So this formula we got from the gravitational force, that calculation. Now today we'll start from the free fall. What is free fall? Free fall means when any object, whether it is very light in weight, whether it is very heavy in weight or medium weight, but when an object or when a substance used to fall from an empty area, or you can say that from the air to the land, so such type of falling is known as the free fall. Okay, you will observe that when you will throw a ball in the sky, so after a while that ball will come back to you. Got it? Or when a cricketer used to throw a ball using his bat, the batsman, at that very time the man used to catch the ball. It means the ball is coming with a force, along with a force, and it is coming from an open area to his hand, so easily it can be caught by that man in the cricket. So in this way, when any object used to fall on the ground, or any particular in any particular object from a free area or open area or empty area, is known as the free fall. Now here, as we are reading physics, so of course we have to go for the substance's mass, then its distance. Okay, what distance it has already covered, so let's go for it. Suppose we have taken the mass of it equal to small m, and the distance is taken as d. Okay, distance taken as d. So from here easily we can say that the m is denoted as the mass of that object, and d is the distance. What is the distance? Distance means from where, from the empty area from where that substance is falling on the ground. That distance is denoted here as d. Now here we are reading the free fall means empty area, or the open area, or open atmosphere. Now in the open atmosphere, when we are seeing at that very time, instead of d, if we take r, that should be better. Why we will use r and why we will not use d? Look, here d means the distance. Distance means the particular area on any surface, whether it will be very plain surface like this, or it will be rough surface. But on any surface, when any substance is to move from, suppose from A to B, when substance is moving, this area can be said as a distance. Okay, but as it is falling in a horizontal vertical manner, means from an open area when it comes to the land, so this area can be measured as r. Okay, why? Because we know that from the open area, when the substance is falling on the ground or on the earth, we know that the earth has the attraction, right? The earth has the attraction, and by this attraction force, this ball or this substance is moving back. Okay, that's why when you are throwing a ball on the in the sky, after a while it will come back. What for? Because our earth has the attraction, and by this attraction force, this ball will go in its particular height, and after that it will come back again. Okay, so that's why this is said to be as a radius of the earth, means which radius, up to which radius from the earth that ball or that substance has gone, and that's why this radius is denoted as smaller, we all know. Okay, now we have to think for the second law of motion. Second law of motion, what is told in second law of motion, or what is the formula has given in second law of motion? It is told that force equal to mass of the object into acceleration of the object when it is in moving situation. Okay, it means that the product of the mass of the mass and the of acceleration, both are said to be in the force. Okay, or force is denoted as the product of mass and the acceleration of any particular object. Got it? This formula we get from the second law of motion. Okay, now as we have already told that the distance from where the open area the substance is falling onto the earth, it means it is about the attraction power or the attraction of the earth. So we can easily say that it is the acceleration, it is also a part of acceleration, but this acceleration is due to the gravitation or gravitational force. As we know that due to gravitational force each and everything are being attracted towards the earth, right? Everything is attracted towards the earth, so that's why we are on the ground, we can walk, we can sit, everything is its own position. What for? Because the earth has the attraction power, and by this attraction power each and everything are attracted towards the earth. Okay, so that's why when the ball is thrown up the sky up to its limitation, it goes and then it moves back. It means up to this portion is its magnitude, the all over magnitude is up to this. Okay, after that it comes back, it means its acceleration is this. So we can say that this is the acceleration of gravitational force of the earth. Okay, and this acceleration of the force of the earth is said as not A by G. Okay, we cannot say it is about A, we can say it's about G. So finally we have got F equal to m into G, F equal to m into G. Okay, not F equal to m into A, but we have read it. And where do we use this A? For this portion. Okay, when we have already read that when we got the constant of the gravitational force, at that time we have told that two objects, one is capital A, one is small m, when they are moving in one plane surface, so what its distance will be small d, then its mass will be capital M, another will be small m, and its acceleration will be small a. Okay, so in this way we have got the point, we have got the formula of it. But here, as we are telling about the free fall, means from the open area the magnitude is being captured or being calculated. So for that purpose the acceleration is changed by its own constant and it is given as small g. Got it? And this small g is denoted as the acceleration due to gravitational force, due to gravitational force. Look, here we haven't told any time that due to gravitational force or due to anything else. Acceleration means only acceleration. Got it? It means it's the ball's speed or the substance's speed, its acceleration according to the magnitude. But here, according to the magnitude, when the acceleration is speeding up towards the ground due to the force of the earth, so that's why it is taken as small g, and this small g is SI unit is meter per second square. SI unit is meter per second square. I think you have understood. Okay. Now we have already told from the constant, when we calculate the constant of the gravitational force, we have got the final value of it, that is F equal to capital G into capital M into small m by d square. This was the final formula of the law of gravitational force, where we have got the constant or the proportional constant of the gravitation, that is denoted as capital G. Okay, now look, we have already got from the second law of motion, according to this free fall, F equal to m into G. So easily we can write here, or m into G equal to capital G into capital M into small m by d square. Can you write? Yes, of course we can write. Now from here, look, here is also small m, here is also small m, so we can easily cancel them from both sides. Okay, so what it will come? It will come as small g equal to capital G into capital M by d square. So we have got our final formula, that is the small g equal to capital G into capital M by d square. Okay, so here small g is the acceleration due to gravitational force of the earth, then capital G is the constant of the universal the law of gravitation, then M, capital M is the mass of the object, on which object we are just telling. This is the mass of this object, so we write here capital M. And d square means the distance, but here will we use this small g? Of course not, we will not use, because we have already told that instead of d what will we use? We will use r. Look here, we have already told. So easily we can say here, therefore sin small g equal to capital G into m by r square, and these r means the radius of the earth. Okay, radius of the earth. Now we know that the earth has the three layers: core, mantle and crust. Core, mantle and crust. Okay, now the attraction power from where it is coming? It is coming of the center, from the core. Okay, so it means here at this dot portion the attraction power is there. It means G is present over there. Got it? So whenever from this equator, from the center, this G will be increases to equator. So at that very portion, the G's value will be greater. Okay, G's value will be greater at the equator portion, and whenever it will come closer to the center, at that very time it will be lesser. It will be lesser. G's value will be lesser. So in this way we can easily understand. And for this experiment, scientist Galileo Galilei, once he visited to Italy, that sliding or tilted monument that is known as Pisa. Okay, from there, from the first floor of there, he just fell two things. For one is lightweighted feather of a bird, and a stone, a piece of stone that is the heavyweight than the feather. Now at a time when he has when he fell all those two things, he just followed that two things have touched the ground at a time. Okay, so from there he proved that the thing, whether it is very heavyweight or lightweight, whether it is when it will come to the gravitational force, under gravitational force, so all those things will be stay, or it will come on the earth at a time. Okay, now we have to go for the next topic, that is the calculation of the value of G. G means the acceleration due to gravitational force. Okay, very good. So from here we can easily calculate, as we know that few of the common calculations, few of the common numbers you have to keep in your mind. That is the capital G, that is the gravitational constant. It's about the 6.7 into 10 to the power minus 11. 6.7 10 to the minus 11 Newton meter square per kg square. Okay, then capital M is 6 into 10 to the power 24 kg, and the radius, okay, we have already talked about the radius, 6.4 into 10 to the power 6 meter. So when you will put all this value here in this calculation, easily you will get the answer G equal to 9.8 meter per second square. Okay, the G's value is 9.8 meter per second square. So in this way you can get the value of the acceleration due to gravitational force. Okay, fine. Just you have to memorize these three numbers, because these are very important, and these are the constant number. It can never be changed. That's why you have to memorize it. Now the next topic is the motion of objects under the influence of gravitational force of the earth. Here I have already given you a hint that whether any articles or any substances, whether it is very heavy or lightweighted, or it is very thin or thick, it doesn't matter. When it comes in contact of the gravitational force or the acceleration of the gravitational force, all the things remain as same value, and it touches the ground at the same time. So that's why where there the air is zero, okay, or there is no air, or we can say that totally vacuum area, in the vacuum area where air is zero, at that places the stone or feather or any thin substances or any lightweighted substances, whatever you can say, all those things fall on the ground at the same time. Got it? Because if you observe that a feather or a ball or heavyweight any articles or stone, when it will fill from a open area on the ground, you will observe that all those things will be touch the ground must, but there will be a um, there the time will be difference. Okay, at first the heavy weighted substance will touch the ground first, then the light weighted substances. What for? Because here the atmosphere means the air is present, and air plays its role in a most amount over here as a resistance. Okay, what for? Because we know that the air has a layer and air used to blow, and by the blowing of the air, the light weighted substances get frictions into itself in its movement. So that's for that purpose the speed of the light weighted substances gets changed at that very time, and it doesn't come on the ground in a proper way. Whether a stone or a heavy weighted substance, when it falls from a um, large distance at that very time, along with its force, it or along with its speed or acceleration, it comes onto the ground very fast, or it doesn't play any role on the friction of the air that happens. So that's why the heavy weighted things fall first. Got it? But in the empty area, it doesn't happen anytime. All the lightweight and the heavy weighted things comes at a time on the ground. Okay, fine. So for these purposes, this acceleration or the acceleration due to gravitational force or g is used in different type of motions of the objects. We have already read in the earlier chapter the three formulas of the motion or the speed of different objects and its formula. Those are v equal to u plus at. Okay, we have already read. Then is equal to ut plus half at square, we have read. Then we have read v square equal to u square plus 2as, or v square minus u square equal to 2as, in this way. So here for every formula we have to use, instead of now in these three formulas, we have to put instead of a the value of g, or the g, that is the this g or the acceleration due to gravitational force, okay, of the earth. So this g we have to put over here, and we have to calculate all these formulas, and we can easily take out the value that will be needed for the questions. So from here we can easily say the g's value we have already understand. Then the u and v, we know that the initial and the final velocity, the s is the distance. Okay, so in this way easily we can take it out, and t for time. Okay, so that's for all for it, and now you have to practice at home, then you can easily understand. First of all, you have to read the topic, then you have to listen to this video, then you can easily understand. Okay, fine.